For over 100 years, diesel trucks have dominated global logistics. Every grocery store, every warehouse, every highway, every supply chain, powered by diesel. But now, Elon Musk has revealed updated 2026 specifications for the Tesla Semi. And if these numbers are accurate, diesel is not just competing, it is under pressure. We are talking about longer range, faster megawatt charging, lower operating cost per mile, improved battery efficiency, and smarter autonomous support. If even half of these upgrades perform at scale, the trucking industry could shift faster than most analysts expect. In this video, we will break down the real 2026 Tesla Semi specifications, how they compare to modern diesel Class 8 trucks, what 1.2 megawatt charging means in real logistics, and whether diesel fleets should actually be worried. Tesla has already proven that electric vehicles can disrupt passenger cars. Now the target is heavy freight. Before we go deeper, if you want serious breakdowns of Tesla engineering, trucking economics, and EV disruption without hype, subscribe to the channel and turn on notifications. Now let us start with the core numbers, because in trucking, numbers decide everything. The numbers that scare diesel. In trucking, emotion does not matter. Range, payload, cost per mile, uptime, those decide everything. So what are the 2026 Tesla Semi numbers that are shaking the diesel industry? 1. Range, the core upgrade. The updated 2026 configuration is expected to maintain two primary variants: approximately 300-mile range version, approximately 500-mile range version. However, efficiency improvements could push real-world loaded range slightly higher than earlier prototypes. Fully loaded at 82,000 pounds gross combined weight, the Semi is designed to deliver consistent highway range without dramatic drop-off. That is critical. Diesel trucks typically run 1,000 miles before refueling, but most freight routes in the United States operate under 250 to 400 miles per day. That means the 500-mile Semi can cover the majority of regional logistics routes without midday charging. This is where diesel starts feeling pressure. 2. Battery capacity and efficiency. While Tesla has not publicly confirmed final pack size, industry estimates suggest approximately 800 kilowatt-hours to over 1 megawatt-hour battery capacity for the long-range version. That sounds massive, but here is the key. Energy consumption is estimated around 1.7 to 2.0 kilowatt-hours per mile under load. Compared to diesel fuel cost volatility, electricity pricing is more stable, especially for fleet contracts. Tesla designs its battery packs with structural integration and advanced thermal management, helping maintain efficiency under heavy load. For fleet operators, predictable energy cost matters more than raw horsepower. 3. Power and performance. The 2026 Tesla Semi continues to use tri-motor configuration similar to Tesla performance vehicles. That means high torque from 0 RPM, no gear shifting delay, smooth acceleration under full load. Diesel trucks require multi-speed transmissions. Electric motors deliver instant torque without shifting complexity. This reduces mechanical wear and improves long-term reliability. On steep grades, electric torque provides consistent pulling power without lag. That translates into faster average trip times. 4. Regenerative braking advantage. One of the most underrated upgrades is regenerative braking. Diesel trucks rely heavily on engine braking and mechanical brakes. The Semi recaptures energy during downhill driving. That reduces brake wear dramatically. For fleet managers, brake replacement costs are significant. Lower maintenance equals higher uptime. And in freight logistics, uptime equals profit. 5. The real disruption metric, cost per mile. This is where diesel feels real pressure. If electricity contracts allow charging at lower per kilowatt-hour rates, total operating cost per mile could undercut diesel. Fuel savings over hundreds of thousands of miles per truck become massive. Multiply that across a fleet of 500 trucks. The economics compound quickly. However, range alone does not eliminate diesel. Charging speed is the next battlefield. Because if trucks cannot recharge fast enough, logistics breaks. And that brings us to the biggest upgrade of all. 1.2 megawatt charging. 1.2 megawatts. What does that really mean? Now we reach the most controversial upgrade. 1.2 megawatt charging. That is 1,200 kilowatts of power. To understand how massive that is, consider this. A typical home charger runs at 7 to 11 kilowatts. A fast car charger runs at 250 kilowatts. The Tesla Semi is talking about 1,200 kilowatts. That is industrial-level energy transfer. So what does that mean for trucking? 1. Charging time. The diesel comparison. A diesel truck refuels in about 10 to 15 minutes. That is the benchmark. If the Tesla Semi can recharge 70% of its battery in roughly 30 minutes, that fits within regulated driver rest periods. In the United States, drivers must take mandatory breaks after certain driving hours. If charging aligns with those breaks, productivity is preserved. That is the key. If charging exceeds rest time, logistics slows. If charging matches rest time, diesel loses its time advantage. 2. Real-world charging curve. Charging is not linear. At lower battery levels, charging is extremely fast. As the battery fills, speed tapers to protect longevity. So the realistic scenario looks like this. Arrive with 15% battery. Charge to 70% in about 25 to 30 minutes. Return to the road. That covers another 300 to 350 miles depending on route. For regional freight, that is sufficient. 3. Infrastructure, the true challenge. Now here is where diesel still holds ground. Delivering 1.2 megawatts per truck requires heavy-duty transformers, grid upgrades, cooling systems, dedicated charging depots. This is not a small charging post at a retail parking lot. This is industrial power distribution. Tesla has introduced the Megacharger system specifically for semi-fleets. These are designed for depot charging, not random public stops. Large fleet operators like logistics companies can install these at distribution hubs, but nationwide infrastructure rollout will take time. 4. Grid Impact 1. Semi-charging at 1.2 megawatts equals the power usage of hundreds of homes. Now imagine 10 trucks charging simultaneously. That is 12 megawatts. Utilities must plan for this load. However, fleet depots often operate in industrial zones already equipped for high demand. Additionally, scheduled charging at night can reduce grid strain. 5. Cost advantage per charge. Electricity at commercial rates is often cheaper per mile compared to diesel fuel. If a fleet locks in long-term energy contracts, cost stability improves. Diesel prices fluctuate with global oil markets. Electricity pricing is more predictable. That financial predictability is attractive to large-scale operators. The big question: does 1.2 megawatt charging eliminate diesel overnight? No, but it removes one of diesel's strongest advantages: fast refueling. If electric trucks can recharge within regulated rest windows, diesel's time advantage shrinks dramatically. And when time advantage shrinks, cost becomes king. That brings us to the real battlefield: total cost of ownership. Because fleet managers do not care about hype, they care about spreadsheets. The spreadsheet that decides everything. In trucking, debates do not matter. Numbers matter. Fleet managers do not care about headlines. They care about cost per mile, maintenance cycles, downtime, fuel volatility, long-term depreciation. So let us break this down clearly. 1. Fuel cost comparison. A modern diesel Class 8 truck averages roughly 6 to 7 miles per gallon. If diesel costs $4 per gallon, that equals approximately 57 to 67 cents per mile in fuel cost alone. Now compare that to electric. If the Tesla Semi consumes around 2 kilowatt-hours per mile and electricity costs 15 cents per kilowatt-hour under commercial contracts, that equals 30 cents per mile. Even if electricity costs 20 cents per kilowatt-hour, you are still around 40 cents per mile. That difference compounds fast. Over 100,000 miles per year, the fuel savings alone could exceed $20,000 to $30,000 per truck annually. Multiply that across a fleet of 500 trucks. Now you understand why diesel is nervous. 2. Maintenance cost difference. Diesel engines have complex transmissions, multi-speed gearboxes, oil systems, exhaust after-treatment systems, turbochargers. Electric trucks eliminate most of those systems. No oil changes, no diesel particulate filters, fewer moving parts. Regenerative braking reduces brake wear dramatically. Less mechanical complexity often means lower maintenance cost. Tesla designed the semi-drivetrain with simplicity in mind, similar to its passenger vehicles. That reduces scheduled service interruptions. In logistics, uptime equals profit. 3. Downtime economics. Here is where it becomes interesting. A diesel truck that breaks down loses revenue. An electric truck that charges during mandatory rest breaks loses nothing. If charging fits within legally required driver stops, productivity remains intact. The key is charging infrastructure reliability. If megachargers are consistently available at fleet depots, downtime shrinks. If public charging becomes necessary and inconsistent, diesel regains advantage. Infrastructure execution decides the winner. 4. Upfront cost reality. Electric trucks typically cost more upfront. Battery packs are expensive. However, total cost of ownership often favors electric over multi-year usage. If the Semi costs more initially, but saves $20,000 to $30,000 per year in fuel, thousands more in maintenance, additional savings in brake replacement. Break-even can occur within 3 to 5 years. For fleets running trucks 7 to 10 years, that becomes compelling. 5. Residual value and regulation. Pressure environmental regulations are tightening globally. Diesel fleets face increasing emissions compliance costs. Low-emission zones are expanding. Electric trucks gain regulatory advantages. If carbon pricing expands further, diesel operating costs could increase. That risk adds long-term financial uncertainty for diesel operators. Electric fleets hedge against that uncertainty. The big picture. Diesel is not dead tomorrow. Long-haul routes over 800 to 1,000 miles still favor diesel for now. Infrastructure rollout takes time. Battery cost must continue dropping. But for regional freight under 500 miles per day, the financial math is shifting. And when the spreadsheet favors electric, industry shifts follow. Now let us talk about the final piece: autonomy and operational efficiency. Because if the Tesla Semi combines cost savings with advanced driver assistance, diesel faces an even bigger problem. The advantage diesel cannot copy. So far, we have discussed range, charging speed, cost per mile. But here is the factor most people overlook: intelligence. Because the 2026 Tesla Semi is not just an electric truck, it is a rolling computer network. 1. Advanced driver assistance. Tesla builds its vehicles around real-world AI data collected from millions of miles. While full autonomy for heavy trucks is still regulated and controlled, advanced driver assistance systems are evolving quickly. Features include lane centering, collision avoidance, predictive braking, adaptive cruise control optimized for freight. For fleet operators, this reduces accident risk, and accident reduction lowers insurance costs, repair downtime, liability exposure. Diesel trucks can install driver assistance features, but they lack Tesla's integrated AI ecosystem. That integration matters. 2. Centralized fleet data optimization. Electric trucks provide real-time data streams, battery health, energy usage patterns, driver behavior efficiency. Route optimization analytics. Fleet managers can analyze which routes consume more energy, which drivers operate most efficiently, where charging bottlenecks occur. Over time, software updates can improve efficiency across the entire fleet. Diesel trucks do not improve with software updates in the same way. Electric platforms evolve digitally. 3. Predictive maintenance. Traditional trucks often follow scheduled maintenance intervals. Electric trucks allow predictive maintenance. If sensors detect abnormal motor vibration, thermal irregularity, or battery performance shifts, alerts trigger early service scheduling. That prevents unexpected breakdowns. Unexpected breakdowns are expensive. Predictive maintenance increases uptime, and in freight, uptime equals revenue. 4. Platooning potential. Although still regulated carefully, electric trucks open the door for platooning. Multiple trucks traveling closely with synchronized speed and braking. That reduces aerodynamic drag. Less drag equals lower energy consumption. Even small efficiency gains become massive at fleet scale. Diesel trucks can technically platoon, but electric control systems respond faster and more precisely.
5. Driver experience and retention of the semi's center-seated cockpit, digital interface, and quiet operation change the driving experience. Less vibration, less engine noise, smoother acceleration. Driver retention is a serious issue in the trucking industry. If electric trucks improve comfort, fleets gain a competitive hiring advantage. That is not a small detail. That is operational stability. And the real disruption in diesel trucks compete mechanically. The Tesla Semi competes digitally and electrically. When cost savings combine with lower maintenance, software optimization, autonomy readiness, driver comfort, the competitive pressure increases. Diesel still dominates long-haul routes. Infrastructure must expand. Battery costs must continue dropping. But regional freight and fleet-managed logistics, the shift has already started. And that brings us to the final verdict. Is diesel truly in trouble? Or is this disruption still years away? Diesel dead, or just under pressure? So after breaking down, range, battery size, 1.2 megawatt charging, cost per mile savings, autonomy integration, fleet optimization. What is the real answer? Is diesel finished? No. But is diesel comfortable right now? Also no. Here is the balanced truth. Long-haul trucking over 800 to 1,000 miles per route still favors diesel today. Infrastructure for nationwide megawatt charging is still expanding. Battery production capacity is still scaling. However, regional freight under 500 miles per day, that is where the pressure is building fast. Tesla is not trying to replace every diesel truck overnight. It is targeting the routes where electric makes immediate economic sense. And that is smart strategy. If a fleet operator can save $20,000 to $30,000 per truck annually in fuel, reduce maintenance downtime, lower brake wear, improve driver comfort, and align charging with mandatory rest periods, then diesel is no longer the automatic choice. It becomes a calculation. And once trucking becomes a calculation instead of tradition, disruption follows. Now here is the bigger shift. Electric trucks are not just mechanical upgrades, they are software platforms on wheels. They improve over time. They collect data. They optimize routes. They adapt. Diesel technology does not evolve through over-the-air updates. Electric fleets do. So is diesel dead in 2026? No. Is diesel dominance guaranteed for the next 20 years? Also no. The transition will not be explosive. It will be gradual, route by route, fleet by fleet, contract by contract by contract. And when the financial spreadsheets consistently favor electric, that is when the real tipping point happens. If you want serious Tesla semi-analysis and trucking industry breakdowns without hype, subscribe to the channel and turn on notifications so you never miss future updates. Comment below, if you owned a logistics company, would you switch part of your fleet to electric right now, or wait for infrastructure to mature? In the next video, we will analyze whether Tesla can realistically scale semi-production to hundreds of thousands of units per year. That manufacturing discussion is where the real battle begins. Thank you for watching. Stay informed, stay analytical, and I will see you in the next one.